So here's our motor class, and let's go find the compare to. And just for fun, we'll say, suppose we wanted it by serial number and then hours of service. Okay, and I'm just going to start this thing from the very beginning and pretend there's nothing there. Okay, so it said the first thing that you wanted to do was compare serial numbers. So that's the difference is the serial number, wherever it is, serial number, and we'll use strings compare to. See how smart string is? It's got all sorts of good stuff in it. We're just going to use compare to. And we're going to compare it to, another dot serial number. And then we said what we'd do is we would look at the difference and we would say if the difference is already different, meaning we didn't get a 0, then we can send back whatever that number is. So again, if it was, Albertson versus Jones, we already know that they're somehow different by their letter positions, so we'll just send that thing back. Okay? And if they're not already different, then the difference needs to be by hours of service. And we can send back that difference instead. Okay, so there's that rejection thing again, right? There's that sort of natural style of, oh, okay, well, if they're already different, then I'm done. Well, okay, if they're not already different, then I have to continue on and find some other difference. And you can just keep extending that. If they were the same by hours of service, then you could go on and choose another field, calculate the difference of that, and return the difference of that. And what you end up getting is a subsort. It sorts by serial numbers first, and then it moves on to saying, well, if the serial numbers are the same, which they wouldn't be in this case, but if they were the same, then we would then move on to hours of service. Okay, so there's an example of a subsort. When you're doing your lab 2, my suggestion in the lab 3 write-up was that you do the same thing when you're searching for people. It's like, well, okay, if they're already different here, then I'm done. Well, they're the same, so now I have to move on and search by something else. So it's sort of the same process for equals also, except this one uses a number. Okay, so I wanted to make sure you'd seen that one. Okay, next thing on my list of goodies is, yes, iterators. Fancy word, simple concept. Okay, so I got this pile of stuff, and the stuff is all numbered, right? So I'm going through it and I'm saying, well, it doesn't have to be numbered. I've got this pile of stuff that's sitting on the floor. If I want to go through it, I pick one up and I go, okay, let me do something with this. I pick up another one and go, let me do something with this. I'm always asking myself the question, what have I got left, et cetera, et cetera. If the pile happens to be a fair distance away, then you think about, well, rather than me doing the work, why don't I get somebody else to do the work of doing the running for me to go get the thing and then coming and bringing it back to me. Okay? So as soon as I start to get lazy, I put basically a third party between me and the pile, and I say, hey, it's your job to now fetch things for me. Okay? So we've got this person who's in charge of fetching things. What are the 2 questions that I need to be able to ask them? There's just 2 questions.
How many are left?
What's your serial number and how many
Not how many. What's the laziest thing I can ask?
Is there anything left?
Is there anything left? Okay, or got anything else for me? Right? Just yes or no. Right? And if they say yes, then what do you do?
Continue.
What do you say to them next?
Okay.
Get it.
Go get it for me, right? Got anything else for me? Yes or no? As soon as they say yes, say, go get it for me. Eventually, they run out of stuff, and when you say, got anything else for me, they say, no. And you go, okay, fine, I'm done it, right? So an example of that is doctor's office, right? You know, any of those ones where there's a bunch of people sitting in a line and, the secretary is in charge of bringing in. That's exactly what the doctor does, right? The doctor walks up to the secretary, says, got another patient for me to see? Secretary says, yes, I do. Doctor says, well, send them in then. Go get them for me, right? Okay. So there's a standard there that says if you're going to get somebody to play fetch out of a pile of things, those are the only two questions that you have to ask. We would call that a gopher, I guess, is about the only sort of Englishy word I can think of. It says, go get this for me, right? In Java, they call that an iterator. Okay? So anytime you see the word iterator, think, oh, it's somebody who's going to fetch things for me. So let's go back into the driver here, where we've got a bunch of things in a pile, which is our list of all motors. And it turns out that ArrayList has the ability to fetch things. So I can say all motors dot. Now I'd like to say get me somebody who fetches things. I'd like to say get iterator to use the correct get terminology, but for some reason here's another naming thing in Java where they just call it an iterator. So that says talk to the pile of things and give me back somebody who will fetch things, and the person who's in charge of fetching things is known as a capital I iterator. And so you end up with something that looks like this. You have to click on the bulb there to get the import statement in, and be sure that you use the one from the utilities class, which is the typical one. So that basically says go to the pile or go to the warehouse or go to whatever and get me somebody who will fetch things for me. So this thing now acts as, instead of gopher, let's call it secretary, and let's use the doctor's office analogy. So it's basically, hey, secretary, here's your pile of stuff. Okay? And we said the next thing you do is you say, secretary, do you have another one? And for that, asking the question, it's has next. Okay? We need to keep repeating that. Well, we need to do it once. So let's play this game. So if there was one thing to do, they said, yes, there is something in the pile. Then what did we say you'd do?
Go get it.
So talk to the secretary and say, please go fetch one of these things for me, which is next. There's another bad word, by the way, because if I say, I'll see you next Friday, in English, some people will interpret that as being this coming Friday, and other people will interpret it as being the following Friday. So it's another weird word. Next here means the immediate one that's immediately available. Okay? So go fetch the thing for me. What kind of thing are they going to give you back?
Motor.
Motor, because that's the things they're holding on to, and that's what that word said. I'm only going to be fetching motors. And then we need a variable for some motor. Okay? And then you could do something like print it out. We'll just print out some motor. Okay? So there's the little pattern. Go find somebody who will play fetch for you. So what you do is you say, you talk to whoever's holding on to the things, and you say, I need somebody to play fetch. They give you back a person who's now going to play fetch. The only two words they understand are, do you have another one for me? And if you do, go get it for me. Okay? Now, here's the nice thing about the way I wrote this. Little trick here. If you can get it to work for one thing, to do all of the things, you change this word from if to while, and it will now do all of them. There's the joy of while loops, right? That's all that you have to do more than one of them. So whenever you're stuck thinking about how do I do a while loop, write an if statement first. Get it to do one of them and change it to a while, and pretty much guaranteed to work. Okay? And this will just go through and print them all out if we're lucky. Let's just put a, oh, I guess it's after found another, so that's fine. We'll run this thing. And there it's printing out the serial numbers in the order that they happen to be, because we sorted them and reversed them, so that's why they're in backwards order. Whatever. But there's the 3 items that were on the list. Okay? Why would you use that pattern? What's the advantage of using that over a counted loop?
You don't need to know how many items are in the list.
You don't need to know how many items are in the list. You don't need to worry about, am I getting the first one or am I getting the last one? You just keep talking to the person and saying, you got one for me? Fine, go get it. And the guarantee here is that they're just going to fetch everything until it's done, and then they're going to say, I'm done. Okay? So what happened was, in programming languages, when this concept came along, people turned around and said, well, this is actually better than a counted loop. A counted loop is nice, but it's really specific, and it has a lot of chance for errors. And since we're going through everything anyway, wouldn't it be nice if we just had a pattern that says, let's go through everything anyway? So that's where this iterator concept was born. Okay?
What's the benefit of this over a for loop? Like,
Well, okay, so now we come to for each.
Yeah.
Okay? Well, what happened was this came before for each. Okay? This little pattern of the while loop actually originated before for each, and then for each came along because people went and said, well, this pattern is just the same all the time. If I'm going through a bunch of students, this is, talk to an array list and get the iterator. It's an iterator for students, while iterator dot has next, go get me a student, do something with it. And so I'm just doing a lot of typing. And so for a while they said, well, okay, we'll do an autofill thing that will magically splat all that code in there. And then somebody said, well, that's just really annoying. Okay? Well, it turns out that when you write for motor secretary, even though it might not let me do that. Well, we'll just use secretary X here. Oh, actually, let's just change this, a motor or some motor. Works even better. It turns out all that they did in Java is that when you write this thing, the Java compiler just comes along and says, oh, you meant that. And notice how almost identical they are. The only thing that the compiler does is it makes up this variable for you. It just uses some arbitrary variable name, and it actually writes that pattern for you, and you don't see it. Okay? And it just saves a whole bunch of typing. Okay? So the bottom line there is this pattern was nice at one time. It got too much to type. This is what the compiler writes for you, but you have to be able to talk to whoever's got the bunch of things and say, go give me one of those fetch type people. Okay? And it turns out that somehow ArrayList has the ability to do that, and so it has that option that allows you to go do the fetching. And that's why it happens to work for ArrayList. Okay, so those are equivalent, and so now we prefer to write this one because it's just a lot less typing, a lot less reading. Okay, so an iterator is just a gopher. somebody who fetches things. And once you've gone and introduced them or gotten the pile of things and them coordinated together, you stop talking to the array list and you start just talking to the person who's going to go do the fetching instead. Okay? And the pattern basically always remains the same. You can always just copy that thing out and use it if need be. Notice, remember, I said while always has the sense of uncertainty. There's that idea of uncertainty. I don't know how many of those things I have to do. I'm just going to keep asking until there aren't any more. Okay, so there's for each. Questions about those? We're going to need this one later. We're going to need this idea later, which is why I wanted to show it to you now. Okay, next thing on my list of goodies let's talk about something else here. Okay, so we've been playing with this thing. Suppose that I wanted to turn this into an assignment for next year's class, a lab exercise, and I want them to write the motor class. But rather than writing out the words, I want to leave all the methods for them so that they can see the sort of stuff that they have to do, just to be sort of nice to them or mean, take your pick. Okay, so what I'm going to do with this thing is I'm just going to make a copy of it so that I don't destroy the original. And I'm going to call it motor empty or something. Okay, and let's just open up motor empty here for a second. So it looks it's exactly the same thing. So now let's start destroying it so that other students will have to fill in the stuff. Okay, so the first thing I'm going to do is I'm going to say, well, let's see, what do we got here? All of this data, I think that should go because you should be able to figure out from the driver program what stuff this needs inside. So I'm going to make all that go away. And then I'm going to say, the constructor, that's another thing that if I show you a sample in the driver, you should be able to figure out what the requirement is for the constructor. So I'm going to make that go away. Equals, you should be able to sort of write yourself. You know that every class needs one, so I'm just going to say you need to write an equals someplace. That should just be written for you. Getters and setters. Well, I was sort of specific here about some of them. So I'm just going to, some of them we wrote and some of them we didn't maybe. So I'm just going to wipe out the guts of them just to make you have to write something in there. So I'm going to destroy all those. Add hours of service I want you to write, so you're going to have to figure out how that's done. Hours of service left, you're going to have to figure out how that's done. Compare to, I've already said implements comparable at the top, so that should be enough of a hint to figure out how to do that one. So I'm going to make you write the whole compare to. Is past service, and make that one go away. And toString, well, you should be smart enough to know that it's just used for debugging, and if nothing else, I'll say write something that will do debugging output. So let's just make that thing go away. I think I got them all. And let's just compress the thing a little bit. So I'm going to say, well, okay, motor empty. I don't even want those braces in there. I'm just going to put those things in there for now, just so I can see them all. There we go. Okay. Pardon the errors, but that's okay for now. So take a look at what I've got left. I can give that to the next class that comes along, and I can say, there's all the methods that you have to write. There's the motor class. I'm telling you how you have to talk to it. You can go look at the driver program if you want to figure out how the constructor works and the fact that a toString is used, and you'll have to figure out the implements comparable means right to compare to. You'll have to figure out that I did some searching on it with index of, so it needs an equals, but there's basically all the stuff that you have to write that's sort of the non-standard stuff. Okay, so here, go off and do it. You figure out what data is necessary. What is that thing, really? Yeah, it's a template. I can hand it out to anybody and say, here, go use it, fill it in. This is sort of what you need. Interestingly enough, it's also a standard. Because if I've got a set of unit tests that are pre-prepared for my code, these are using the same names as all of the stuff in my unit test. And so conceivably I can write tests and say, hey, you go write this code, and when the code works, you know, against my tests, I'll buy it from you. Okay? The other way that this thing works is that, you know, I may have had some idea of what a motor was. You may have had some idea what a motor was independently. Guess what? If we're writing for the same sort of problem, we're going to end up with something that looks really similar, although the words we use might be different. Okay? And so the strategy is, oh, well, okay, if we're going to compete with each other, maybe what we'll do is we'll come up with a standard so that now you can have one of them, I can have one of them, and we can sell the same sorts of products. Okay, so you know, even warehouse guys, it's like, well, if you come and use these words in the warehouse, then it's good if there's another warehouse in town that uses the same words, because I can steal your customers. So having a standard there is appropriate. Okay, so this thing is essentially a standard. It's sort of like putting a sign on the door and saying, I speak motor here, right? These are all the things that a motor does. You know that, trust me, you know, this is everything that a motor can possibly do. Okay. Notice the interesting thing about these standards is that they usually come about after you've done one or two. They don't usually come about by somebody sort of thinking, oh, I wonder what a standard would be. Let me think of all the things that you could possibly put into it. You sort of have to have used it, and multiple people have to have done sort of the same thing before you go, hey, we're all sort of doing the same thing, but it's a little bit different. Any of you ever been to another educational institution and tried to register? Like go to UVic, right? It's like if you go to a different educational institution, they use slightly different words for doing the same sort of stuff, and sometimes you have to provide them with this little extra piece of information there, but you don't hear. Wouldn't it be nice if all of the educational institutions in BC came together and said, we'll make a standard, right? When you walk up to the registration people, you can say, I want to register. Here's the information that I need to register. I want to pay my fees, right? You come up with basically a set of words and a set of things that you're going to give them and what they're going to supply back. And now they put a sign up on the door that says, I speak standard BC registration. And when you see that sign on the door, you know that you can basically go to any of those institutions and know exactly what words that they're going to speak. So this thing, motor empty here, is really, it has a different name. It's sort of like standard motor. Okay? And so I just have to get some syntaxy things out here before I can change the name on it. So what I'm going to do here is, instead of using the word class here, I'm going to use the word that means a standard. And in Java, that thing is this word called interface. Okay, and we're almost right here, except I have to say extends, maybe, if I'm lucky. There we go. It uses a silly word to do that, but it sort of means the same thing. Okay, and notice all of a sudden, as soon as I change that to interface, it's a standard, then all of a sudden it says, oh, okay, you're fine now. Okay. And I'm going to change this thing to, instead of motor empty, I'm going to refactor it. And let's just do the rename here, I guess, just to be sure. Rename, and we're going to call it motor standard. Okay. Well, if that's the standard, then since I got it from all the motor stuff, I'm just going to change this thing, and I'm going to say implements motor standard. And, yeah, almost. Pretty close. Okay? And so that says, I do all of the stuff that standard motor does, which is no surprise because that's where it came from originally, right? And I'm just going to make one other little change to this. It turns out that my compare to now has to be not for just my motor, but it has to work against anybody's motor. So this word here actually has to be motor standard. And if that word's motor standard, then I can't use my rule about same type of object anymore because it could be some other slightly different type of object. So this thing has to go back to get serial number to talk like regular people do. And this one has to go back to get hours of service. Again, because it's now not quite the same thing. And that takes care of that. Okay. So now basically what I've done is I've derived a standard from what I had originally. Okay. And now what I do is when I give you the assignment, all that I do to you is I say, I want you to write code that meets that standard. And I don't show you my original code. Okay. So now let's pretend you're doing the lab exercise. If you're doing the lab exercise, what you're going to do is you're going to write your own motor class. So I'll go in and I'll write my class. So this is specifically my version of the motor class. Okay. What would I do here in order to make it do the standard? If you compare against the standard. With copy paste, what would be the simplest thing to do? Yeah, go grab all of this, the guts of this thing, that are the things that I'm supposed to write, and copy and paste it into here, and go, oh, okay, that's, I guess, the starting stuff I have to write. And then proceed to change these to braces and figure out, oh, what should get serial number do? Oh, well, I guess I need a serial number as a string because it's going to return a string, and work my way backwards to now filling out my version of all of the motor code. Okay? There's a shortcut for that in Eclipse. Oh, and then after I got it written, I would proudly, at the top of the thing, say, oh, guess what? I now implement standard motor. Okay? Announcing that, hey, I do the same thing that yours does. We talk exactly the same. I just might have different code and different names for things inside. Different if statements, however it's written. Okay? Well, the shortcut in Eclipse is rather than putting implements motor standard on afterwards, it's actually sneakier to put it on before, because if we proudly announce that we implement the standard, Eclipse comes along and says, well, you don't really, because you're missing a bunch of stuff. And it's sort of hard to see there. I'll see if I can get it over. It says, there's all the stuff you're missing. So guess what? If you click on our friend the bulb and say, write those for me, it comes along and it basically writes methods that do nothing, that meet the standard. Okay? So notice for integers, it's just returns zeros. For things that are objects, it returns null, so it's totally useless, it's broken, but it meets the standard. People can ask you all of the standard questions, you just won't do anything. Okay? And so then this becomes your starting point to say, well, okay, I took the template, and now I can go in and I can write my code, and when my code is done, I know that it will meet the standard, and therefore it will pass all of the unit tests for the standard, and then I can go get it handed in as my assignment to Daryl, knowing that it's all complete. Okay? So that's what an interface is. In Java, most of the time, you'll see people will write this as motor interface, which is what I've done for your Lab 4, or I've seen a lot of people who are too lazy to type interface, and so you'll see it as iMotor for interface for motor is the other thing, which every time I see it, I go, iMotor, I means interface, okay? So I just prefer to write out the longer word for it most of the time. But there you go. Now you can turn around and you can fill in the code, and as you fill in the code, you can run it against the unit tests until all the unit tests succeed, and then you go, okay, look, my motor works. Okay? So for your Lab 2, that's exactly what I've asked you to do, is I've given you a couple of interfaces, or sorry, Lab 4. I've given you a couple of interfaces, and I've asked you to write to that standard to get the thing to work. And in this case, I've made you supply the unit tests. Sometime later on, I'll just supply the unit tests and say, hey, make it work. Okay? And while we're talking about Lab 4, there's only 2 classes that you have to write. The first one is a class for a race car. So we're basically going to try to keep track of, write a program that does all of that stuff you see at like the Indy 500, where they show the race cars, and as they do laps, they increase the lap counters for all of the racers. Okay, so a race car has just basically got a driver in it and a car number, and the car number is actually the unique identifier for racing. Okay, so that's the equivalent of serial number. And the race car is in charge of recording how many laps it's done, and sooner or later it's going to get a sticker put on at the end of the race saying, here's your position that you got, that you recorded in the race. Okay? And the other thing that race cars have is you can be disqualified sometimes, so there's a Boolean for whether or not you're disqualified, and if you're disqualified, you can't make any more laps, and so regardless of how many times you go racing around the track, after you've been disqualified, they just go, no, we stop counting here. Okay? And after you get all of the stuff done for a race car, then you can write a race class, and a race has a name for the race, Indy 500, Indianapolis, 500 laps, got it, and then it's got just a list of all of the cars that are entered. Okay, and what the race is going to do is the race is actually going to serve like a race caller, and you can think of there's a main program, and in the sample main program, what it does, might as well go look at sample main. So here's Lab 4. And if you look, I wrote a sample main program for you. And what the sample main program does is it does basically the registration, right? So there's the setup for the race. It's an Indianapolis 500. It's got 500 laps. We're going to add a bunch of Southern race car drivers. Okay. Then at some point, the race is going to start. When the race starts, basically all that happens is the race caller is just going, oh, okay, somebody's done a lap. Car 40's done a lap. Car 12 has done a lap. Oh, look, car 23's done a lap. So they just record the fact that somebody did a lap. Somewhere along the line, they say, oh, look, somebody got disqualified. Bunch more laps happen until the race is presumably over, because that number is at least 500 for some of the people. And then when the race is finished, we're going to print out the winner. We're going to find who had finished position number 1 out of the race to print out which car and driver won. And then we're going to go through and we're going to print out all of the people in the race. And you don't know quite how to make this for each loop work yet, but there's the idea. Okay, so I'm trying to make it do sort of a real life thing. Okay, so back to where I was. That's how we got onto interfaces. I gave you the interface files for those things. If we go take a look at them, back into source, there's your race car interface file, and oh, look at that. It's got nothing but the name of the thing, and there's the methods that you have to write for this thing in order to make it work. So a bunch of getters, get the driver names, somebody comes along and says, oh, your race car, record that you added a lap, etc. So same deal, there's your assignment, right? You get to write the thing. When you get this thing to work, both of those pieces of the puzzle to work, it should run my driver program and do the right thing. Okay? Okay, so there's interfaces in a nutshell. Let's just go through my little list here. I think I've got something else I want to talk about. Oh yes, a reminder, interface files you're never going to modify because they're the standard. So once somebody comes up with the standard and says this is what you have to make, you're not allowed to change it. Okay? Now the question is, can you do extra stuff? So you can do things, you can say, I meet the standard, but oh, by the way, I do extra stuff. Or you can say, I meet more than one standard, right? So you can put a sign on the door that says Spanish spoken here, and you can also do comma French spoken here to say, I meet more than one standard thing, right? So it's perfectly legal to make more than one standard. The standard is the minimum. Okay? Well, so now let's talk about what it means in this case. If I can find my driver again here. Way back at the top, I declared list this way. Now here's the reason why those two things are different. The thing on the left-hand side is the standard. So that says, I speak list. It turns out that there's different ways of maintaining a list internally. You could maintain it in a database, you could maintain it in an array, you could maintain it however, right? So this thing on the left, on the right-hand side says the particular way that somebody chose to solve this problem was to, in this case, use an array underneath to hold on to the things that the list had. But array list meets the standard, and so it says I speak list. I do all of the things that a list does. There's an add, there's a remove, there's a get by position. All of those things are available to you by virtue of the fact that I said list. Okay? So now you understand why that word is there. What happens if I do this? Still works.
But you can't use any other kind of list.
So what's the difference between the saying list versus array list on the left-hand side?
It's more things to the standard.
List is a broader standard because then you can have different types of lists, whereas if it's an array list as your standard, then you can only have an array list.
Other way around. List is actually a more restrictive version because this says I might do list, you don't necessarily know, but I can do more than a list allows, and I might use more than a list allows. Okay? So if I say list on the left-hand side, that restricts me to only using the stuff that's in the standard. I can't use anything, any extra stuff as I go along and speak. Okay? But if I say array list on the left-hand side, I'm saying I'm going to use all of the features of array list that are there, so if array list happens to do something extra that list doesn't do, I can make use of it. But now since you're using more than the standard and you're not restricted to the standard, people are stuck with array list forevermore. They can't just replace it with a standard one anymore. Okay, so that's the difference between the two. Normally, you'll see it written this way. You're saying, I just want to use the standard stuff that list does. And we'll see you tomorrow.